human beings, we're wired to be connected. From birth, we look for that connection. Where internet connectivity ends and a non-connected society exists, the desire exists to be connected. Once they find connectivity, this city starts to grow. It grows first from an educational perspective.
No longer can the top 3 goals of education be reading, writing, and arithmetic. Now I truly believe that they need to be relationships, relationships, relationships.
Exploration is not a bucket list where you simply check off places that you have been. You need to realize that you are in a frontier and there's always new discoveries to be made, oftentimes just by changing the way you make the observation.
You're exercising a muscle here every time you exercise empathy, and that's emotional intelligence. Continue that curiosity. Ask questions.
Because of that respect and my willingness to listen and his willingness to listen to me, he ended up leaving the Klan, and there's his robe right there.
This is the world we're playing with right now. And the reality is that we don't really know how it's going to look and what it's about.
So many people are looking for feeding their spiritual hunger. The human nature gap is real. The human nature gap is having ramifications.
What if we take an idea and then we embrace it, challenge our belief systems, challenge our perspectives? And today we're going to take one step beyond, and we're going to go that way and just seek new ideas.
Welcome to TEDxNaperville. Welcome to our virtual salon. I'm so glad to be here with you this evening. Before we get started, a couple quick announcements. I'd like to thank our partner for the evening. Our partner tonight is nomorewebinars.com. And we're going to wait for Jonathan to pull up the slide. There we go. If you're tired of webinars, and I think most of us are, check out nomorewebinars.com. Back to the show. This year, you're not alone this year. You're not alone this winter, especially in the Chicago area. TEDxNaperville has committed to be doing one of these virtual salons once a month. We will be doing these on the last Tuesday, most likely the last Tuesday. It could be the third Tuesday of every month. And we already have a speaker lined up for February. On February 23rd at 7 p.m., we have Professor Lucas Parra, who will be talking about biosynchronization in media. It's a really fascinating topic. While we're producing this, I'd like to introduce Jonathan, our producer. Jonathan, can you come up real quick? Jonathan, say hi to everybody.
Hi.
Jonathan is in Nashville. Being that we're virtual, we have some advantages. Jonathan is part of the leadership team, and he moved, and he will be running the show from Nashville. And our guest is remote too, from the California area. Before we get started, if you're watching on the YouTube, don't forget to click and subscribe. If you like this salon, please hit the like button. And we are looking for volunteers this year. TEDxNaperville has some exciting things planned for this year that we're not announcing yet. We are looking for people to join our team. On our website, TEDxNaperville.com, there's a link to participate. And we're always looking for partners and speakers. We'll be having some announcements later. The next couple of weeks or months, we'll be announcing what's happening, but we do have some exciting things in store for you this year. It may not be what you're typically used to, but some very exciting things. Now I'd like to introduce our guest speaker, Jack Gilbert. A quick story about Jack is to say he's very passionate about the topics of microbiology and dirt. And we had him host a dinner when we had the in-person salons a couple of years ago. We had dinner served, and Jack had a full plate of food. He stood up to start speaking, and an hour and a half later, he finally sat down, never touched his food. That's how passionate he is. So I'm really excited to bring on Jack.
Hi,
And
how's
Jack,
it going?
welcome to the virtual TEDxNaperville Salon stage.
Yeah, thank you very much. Great to be here. Cheers, Arthur.
And to let everybody know before I pass it on to Jack, tonight is going to be very interactive. Jack's going to kind of run the show. He has too many things to talk about. So where he goes with this, I have no idea. I know it's very exciting when we prep for this. There's a lot of different directions we can go. But please, on the YouTube comments, ask your questions. We have a moderator watching that, and Jonathan will be able to bring up the questions onto the live stream. So if you have any questions at all, please drop them in the comment section. And with that end, I'm going to introduce Professor Jack Gilbert. And I know the topic today, and I'll get you started, was about you hypothesized that we need to bring dirt back into hospitals. So I know a lot of people are probably curious what that is. So please explain.
Yeah, that's an interesting way of saying it, and probably an inflammatory way of saying it. Dirt into hospitals is probably the antithesis of what most people would want to hear about a hospital, and rightly so. What we're talking about is more targeted bacterial therapies, right? The idea that microbes in hospitals can be controlled by other microbes, almost a biocontrol, but for hospital pathogens. And it stems from a lot of work that we've done and others have done that have demonstrated that the buildings that we've created for ourselves, our hospitals, our homes, our offices, are lovely places for us. They really do favor our needs in terms of humidity and temperature and staying out of the rain. But they are quite like a desert, right? They're like a dangerous place for bacteria, mostly because the kind of bacteria that find themselves living in a hospital or in an office or in a building, they don't really like low humidity, medium to low temperatures, lack of nutrients. They really are like, as one of my graduate students, Sean Gibbons, once said, a desert ecosystem for the bacteria. And so the vast majority of bacteria, when they find themselves in a building, end up dying. And the few that do survive are extremely good at survival. And as you can imagine, for a lot of survivalists, think Mad Max ideology, those ones that do survive are often the ones that are most dangerous for us. So what we found is that a lot of the bacteria that we find in our hospital environments that are alive and thriving are also those that can cause disease if a person in that room is susceptible to that disease. And what we are proposing is not so much to introduce dirt as is to introduce these precision biological therapies to add bacteria back into that building to tackle those pathogens that can survive. There are good bugs that can survive as well. They just don't often find themselves living in a hospital. So by introducing those bugs, we can have them actually outcompete the bad bugs. And thereby significantly reduce the possibility or probability that a patient will suffer from an infection during their stay in the hospital. A lot more to unpack there, but that's the central premise.
But definitely a lot to unpack. Is there a valid approach to double down on sterilization and get rid of the bad bugs? What's the path of least resistance?
Yeah, and this is where it becomes complicated, right? Because the obvious strategy would just be to continually sterilize everything, and that's possible. I mean, if you use something like copper, for example, or a surface substrate that has an antibacterial agent in it, it's possible that you could eradicate all microbial life all the time. But you'd have to coat every single surface in a room with copper, for example. And though surface materials with antibacterial agents in them, well, microbes could find a way, I'm not saying they will, but they could find a way of adapting to those and becoming resistant to the antimicrobial agents we use. Remember, right now, you and I, sitting in our individual rooms, are emitting close to 40 million bacterial cells every hour, right? That's like the population of LA and New York combined being released from our bodies every hour, even when we're just sitting here sedentary. They come out through our oral cavity. They come from our skin. They leave our body via our hair, via gases we release, as you can expect. So we are the propagator of the vast majority of these microbes in the space. So if you sterilize a room, if you want someone to use it, a human being to actually go in that room and interact with it, they're going to be depositing bacteria back into that environment. And we find this, I can identify which person is in a room based upon the microbes that they've left behind, right? So that's interesting and has potential forensic applications. But it also talks to the fact that you leave behind this microbial signature. And so it's technically impossible to continually sterilize a surface unless you're willing to constantly clean or use materials that will continually kill things on a regular basis, which can be expensive. There are other strategies, but reducing the biomass over time would require something that was pretty constant. Now, that doesn't mean that the current cleaning protocols that we're using are ineffective. They're actually very, very effective. They keep millions of people alive every single year. So what I'm advocating is for not a complete cessation of the existing activities, i.e., we're not going to get rid of cleaning, but to actually introduce a new intervention on top of existing cleaning strategies to, if you will, mop up the bits that these cleaning interventions can't touch. And these are ridiculously cheap solutions that could be applied in hospitals, not just in rich countries like America, China, or Europe, but in countries that don't have the kind of income that would allow them to sterilize their hospitals in the way that developed nations can. So it provides an opportunity to introduce mechanisms that could be more universally applied and therefore benefit more people.
I still go back to that. Every hour we're shedding 40 million bits. I think a lot of people are kind of weirded out. But so you're saying that, like, in the future, like a developing country could, to sterilize the operating room, they have like a spray bottle and they would be spraying. I mean, how would you even?
The idea would be you would sterilize the surface with your existing bleach or ammonia solution, making sure that you'd eradicated as much of the microbial life as possible. And then post that cleaning, you spray solutions of these bacterial spores, like little seeds of bacteria. We use a particular organism called Bacillus subtilis. And you can actually buy cleaning products on the market now that contain these spores, right? It's not far-fetched. They do exist. The idea is, though, to then coat the surfaces after you sterilize them, coat them with these bacterial seeds, almost like a lawn of beneficial microbes, and use that lawn to prevent the establishment, persistence, emergence of pathogens that may have left the patient's body and found themselves in what would have been a barren landscape. I like to think of it as akin to taking a weed or maybe a potted houseplant and throwing it down into the Amazon jungle. It's just not going to survive, right? It'll be outcompeted and eradicated almost immediately. That's what we're thinking about doing, is creating these biologically viable surface materials. And by putting a bacterial lawn on those surfaces, we can prevent the dangerous pathogens from getting hold and finding their way in and creating little cultures and colonies which could then reinfect people in the room. It's pretty interesting.
I'd say very, very fascinating. Now, I don't know if it's a weird question, but what about, how do you know that the good bacteria will take over the bad bacteria? The old story, they need to get rid of the frogs. They bring in the snakes to get rid of the frogs, and the snakes take over, and you get to bring in the rats to get the snakes. Is there any danger of disturbing the balance of the bacteria of this approach?
Yeah, I mean, of course there is. I mean, the horse killed the old lady, as I seem to remember, and those it just just by continually trying to mop up your prior intervention with something bigger and better, that's not a good solution. So, what we've been going after are established ways in which these microbes exist and interact in buildings already. We created the buildings, right? We've already manufactured it. We're not going into the prairie or into the savannah and trying to ecologically engineer that environment, right? It's too complex. We don't understand it. We've created these biologically desertified environments, right? They are our deserts. There's very little microbial life which can survive in most homes, and so it's kind of up to us to continually improve the engineering of built environments to reduce the potential impact of these pathogen spread, of pathogen emergence. I think we can all get on board with that in a time of COVID, right? We don't want viruses and bacteria.
Well, I'm glad you mentioned that. How does this all? And somebody asked, how does this relate to COVID? Where you're talking about bringing in, good bacteria. How does that relate to COVID? Is that, yeah?
Yeah, it's complicated. However, what we've shown recently in really cool work from our lab and from a collaborator in St. Jude's Hospital down in Tennessee called Jason Roche has demonstrated that bacteria and viruses like flu, and now we've shown SARS-CoV-2, which is the virus that causes COVID-19, they can stick together. So, you've got a big bacteria like this, and then you've got these little virus particles all stuck around the outside of that bacteria, which seems, well, okay, why does that even matter? What's the point of that? It just so happens that the vast majority of respiratory pathogens, so bacteria which cause illness in our lungs and our breathing airways, those are the bacteria which the virus, like flu, like SARS-CoV-2, likes to stick to. So imagine this. Imagine you're a virus particle and you get inside a host's lung system, and just so happens as that person already has a Staphylococcus aureus infection, a Staph aureus infection, or a Pseudomonas infection, or some underlying non-clinically manifested disease in their lung. Suddenly you find that there's these bacteria there that you can stick onto. And that does two things. And number one means that if you got ejected back out of the body by a cough or a sneeze, you're more likely to be able to survive outside of the body and to transmit more readily to other people or things in the environment because you're on this large globular organism that can be more readily transferred and get inside another person. And also, if you land on a surface like a tabletop or a doorknob, you're more likely to survive because you're living on the surface of this bacteria, which is covered in mucus and in a way polysaccharides, and that helps you to survive in this dry desert-like environment you find yourself in when you're in the built environment. So it's beneficial for a virus. For the bacteria, it's beneficial because that virus particle acts like a lock and a key mechanism for getting inside human cells. So now you've got inside a person, you've bound onto their bacteria, they cough, and that bacteria now gets transmitted into the lung of somebody near that person, right? And once it gets inside that person's lung, it's got all these virus particles on the outside, which allows it to infect the cells of that new person much more easily. And now the person gets a virus infection, and just to make it awesome, a secondary bacterial infection. And that's what would likely cause them to travel to the ICU and unfortunately, in certain instances, die because of the infection. So we've demonstrated this in ferrets, and that's an entirely different story, that ferrets without bacteria don't transmit viruses like flu as easily as ferrets with bacteria. And we've shown that SARS-CoV-2 can bind to the outside of those bacteria. And we've shown in hospitals, in ICUs that have SARS-CoV-2 patients in them, that these bacteria end up in the built environment on the floors of the ICU, and they have virus particles associated with them. And so the paradigm is, if the virus particles are hitching rides on dangerous bacteria that can survive in the environment, and that's increasing the transmission of the virus, then can you just kill off the bacteria? Yeah, you can clean the floors, but what if those bacteria landed on our microbial lawn they couldn't survive, hence the virus couldn't survive. Ergo, you reduce one route of virus transmission that you would otherwise normally have had in this system. And so we are exploring that. I mean, again, as with all of this, to say that the scientific community was caught off guard by coronavirus would be disingenuous. There's been hundreds of researchers working on coronavirus for many years, but with the enormous number of scientists that are now focusing their research objectives, like us, on coronavirus infection, transmission, we're now uncovering all of these novel mechanisms which open up an entire new suite of tools that we can use to try and reduce its transmission and potentially tackle both this and the next pandemic.
So and please, if you have a question on YouTube, just put it in the comment section. So are you kind of saying that one of the reasons why with the COVID outdoors can be so much better for you is not only from the wind and the air, the dispersion, but from the environment, that we have these sterile desert-like environments indoors, and that could be part of the issue versus being in an outdoor, more bacteria-friendly environment?
Yeah, I mean, well, okay, with COVID and SARS-CoV-2 transmission, the reason outdoors is better is just dilution, right? As the Victorians said, dilution is the solution to pollution. I think my mother told me that. But the paradigm is that if you're in a locked room, or not locked necessarily, but in an enclosed room, and there's one person with SARS-CoV-2 and one person who hasn't yet been infected, the person expressing those SARS-CoV-2 particles into the air. Remember, these are very small viruses; they can stay in the air for quite some time. The build-up and concentration of the particles in that enclosed space means that uninfected person is more likely to be infected. If you're standing outside, the wind is going to blow the SARS-CoV-2 away and therefore reduce the likelihood that you will be infected. So it's literally just that. It's dilution because you're outside and there's not this opportunity for the particles to build up and concentrate in the airspace.
Yeah, and I understand that, but is there an argument saying that if you're in if you're with somebody who has COVID in two different indoor environments and one's bacteria friendly, one's this desert, does that have any play?
Yeah, but that's a hypothesis that we have, right? Yeah, I mean, like if you had one room that has lots of potted plants, a couple of dogs, a guinea pig or two, who knows, lots of biological life outside of just the human in the space, and it's not being overtly sterilized, there's a possibility that environment would be less likely to allow transmission of the virus. We don't know if that's true. I haven't got any evidence to support it. It's purely a hypothesis, right? I wouldn't recommend people rush out and suddenly buy a load of animals and plants and put them in a room and say, yay, I'm COVID protected, because that would just be crazy. But what we hypothesize is that, a more biologically rich environment is likely to reduce the probability that a pathogen will build up to sufficient levels to enable contamination. Now, I say that with this proviso. All of the work that we've done in that space is focused on bacteria. To say that could work for SARS-CoV-2, we just don't know. If this idea of SARS-CoV-2 hitching a ride on the outside of a bacteria is true, and that promotes the transmission, then yes, there's a possibility that having a more microbiologically rich environment could play a role in reducing the transmission of the disease. However, we don't know that that's true. Remember, this is an airborne disease for the vast majority of its course, and so just being in that enclosed room and breathing the same air as the other person, that's where the risk comes in. That's why the mask is so important. Such a simple and easy solution, because it will interrupt that primary transmission pathway, by which we think 90% of SARS-CoV-2 transmissions are from breathing in the virus particles that are in the air around someone who's infected, versus maybe 5 to 10% from transmission to your hands from touching a surface or picking up an infected something and then putting it into your nose and mouth. Hence the reason we recommend face masks and hand washing, right? Because that will account for pretty much 99.9% of all potential routes of transmission. But yeah, I mean, SARS-CoV-2 is a unique and flu are unique beasts in that context, right? Not necessarily unique, but that's the problem with those airborne transmissible viruses versus pathogens, which can cause multi-drug resistance and lead to massive complications in hospitals and care homes.
Got it. So outside of COVID, you talked earlier about these microbiological friendly environments, and that we have these deserts, these manufactured. You kind of alluded to it. How do you bring that friendly microbacteria into your home or office? How do you is it simple?
I mean, this is
guinea pig and a dog.
The one question I get most nowadays from the general public and from reporters, etc., is all of this sterilization that we have ongoing right now going to affect my children or my health? Right? Somehow is having too much cleanliness in our homes going to impact the health of my children and my own immune health? To unpack that, I mean, we did write a book in 2017, which the title of which was "Dirt is Good," and the problem with that premise is that the ideology that suddenly you're cleaning a lot more and might actually harm the immune system of your children and harm your own immune system and make you sicker. What I like to say is that it's an easy fix to that. If you have to clean your home a little more because you're worried about COVID, but you want to make sure your child's immune system develops properly, then there's three things you can do. Make sure they can physically interact with a furry pet. So get a dog and let the dog lick their face. Talking about a 2-3 month-year-old baby and playing around with the dog makes a great photo opportunity and will help to promote the immune system of the child by training their immune system to be healthier, right? Or allow the kid outside. If you have a garden or if you have even a window box or you're just growing some vegetables inside, get the kid playing with the dirt and the soil and the plants, right? Or take them down the park or out for a walk in a forest. Allow the kid's immune system to be trained by the environment, and that will overcome 90% of any issues. Yeah, I'm making up a percentage. That's not a real, I haven't calculated it. But most of the issues associated with over-sterilization can literally be handled by allowing the child to interact with things which will help to train their immune system. That's why kids stick things in their mouth all the time,
Yeah, it sounds like grandparents' wisdom. Get a pet, go outside and play, and go plant something. Now, you say that's for children. What about adults? Is it too late for adults to?
I mean, if your immune system is the product of pretty much the first 18 months of your life, and then there's various things which shift over time, especially during puberty and then during old age, right? That lead to the senescence of the immune system in older age can lead to other complications. But yeah, pretty much from the age of 2 or 3 onwards, you are immunologically set with the trajectory you have. Now, we're trying to overturn that. There's opportunities and ways we think that we can manipulate the microbiome to tackle diseases such as asthma, food allergies, eczema, allergic diseases, which may have resulted from a lack of early life exposure to immunological stimuli, or, and this is another entire topic, dietary influences which have eradicated organisms which could cause allergic disease. However, for the most part, I mean, adults are very, very unlikely to be negatively affected by lack of exposure to these outdoor stimuli. But that being said, the vast majority of your health is going to be predicated on a little bit of exercise and a good diet, right? If adults could keep to that, try to walk 10,000 steps a day and eat about 25, 30 grams of fiber a day, you'll probably be fine. That's the best way that humans can deal with it. But I'm not going to say you shouldn't get a furry pet as well, because there are a lot of dogs out there that need homes. So you could go and rescue a pup and bring it in, and it very much likely will help to stimulate your immune system. But it's unlikely to change the trajectory of chronic immune diseases that might be present in you. For that, we might need something a little bit stronger, a little bit more targeted. But we just, at the moment, don't know, because the interventions that could lead to that haven't yet been performed.
I'm going to pull up a question from Jonathan. What dog do you have? We have to assume you have a dog, correct?
Yeah, I have two mongrels. One's a border collie mixed with a Pyrenees mountain dog, and he's got very tall, stilt-like legs, and a big fluffy tail and a very handsome face. And then we have a Pomeranian mixed with a Corgi. We say he's the Queen's Pomeranian, but he's a nightmare. So I don't like talking about him. No, he's a lovely dog. But so we got two pups. We've had them since my kids were very small. We think that they probably have played a role in helping to shape their immune systems because they're both pretty immune healthy. That and eating a healthy diet, obviously.
It's amazing. We have a question, Jonathan. You want to pull up the bacteria disease compared question? See, why before we had more bacteria disease compared to now? Is it because of virus evolution?
I don't think that that's entirely true. If I interpret that question correctly, you're saying sometime before we had a lot of bacterial infections and not so many viral infections. If you think back in historical time, the big infections of the day were people think of are bacteria, like the plague, right? Yersinia pestis, a nasty little bacteria that still affects some 200 or 300 people in the developed world even today, right? And it does every single year, right? We hypothesize, there were still viruses. Polio was a good example, which was crippling and killed millions of people. Measles and various other virus-borne infections, which again were horrendous, right? So smallpox. These are viral infections which were massive problems and have been eradicated with the use of vaccines for the most part. So I wouldn't say that we've have more or less bacterial and viral infections. I would say with the changing climate and the continuing migration of human beings into landscapes that are predominated by wild animals, we're going to see a significant increase in the probability of these pandemic viruses breaking into human populations because proximity to these reservoirs of viruses in wild animals. And so that's going to potentially become an increasing problem. And what we do see is that most of these animal reservoirs do appear to be of viruses, not necessarily novel bacteria that are going to cause infection. So it's far more likely in the future that we'll see more viral pandemics than we do, say, some kind of mass bacterial epidemic. And remember, our antibacterials, despite being overused and causing widespread multi-drug resistance, are still an incredibly phenomenal resource for eradicating bacterial infections for the vast majority of cases. And so while we say we worry about bacterial infections, we still have a better suite of tools for getting rid of them than we do for the vast majority of viral infections. The antivirals we have out there are very targeted towards particular types of virus, and so are less than usefully effective against new ones that come into the scene. So, I mean, it's the world might be changing in the next, say, 100 years or so due to increased possibility of these kinds of animal transmitted infections, the environmental etiology of disease, as it were.
Yeah, fascinating. Now, Laura Mick has a question. We're going to pull up that if our immune system is set in the first 18 months, what is your stance on probiotic supplements for adults? It's a
very good point, actually, Laura. And the issue with this is if you have some kind of, I'm not saying immune sensitivity, be the wrong phrase, but let's say you had some kind of immune disorder. There are a number of clinical trials that have demonstrated that regular consumption of a probiotic can be potentially beneficial, i.e. Compared to a negative control group not taking or taking a placebo probiotic, those that received the probiotic did show some improvement in their condition. And that's widespread, right? There's been those for things like depression, anxiety, for diabetes, for some kind of allergic diseases like eczema, not so much for asthma, but for various other conditions. So there is demonstrable evidence to suggest that some probiotics, when taken in the right quantities at the right time, can produce some improvement in disease states. There is no evidence at all that regularly taking a probiotic when you're healthy can provide a prophylaxis or make you even healthier against disease or in that context, right? So it's not like we know that, I don't take a probiotic regularly. There's no evidence yet that taking a probiotic can help to keep you healthy. However, that may be because we don't really understand how to measure health. I mean, Arthur, are you healthy? Am I healthy? What is healthy? Most of us don't really know, and it's very hard to quantify. It's easier to quantify disease, right? So clinical trials set up to monitor whether something has improved your health or maintained your health are destined to fail. And so, it's not necessarily controversial, but it's a difficult question to answer because we don't really know how to test it scientifically. And that leaves open, right? There is one interesting study, though, where they gave people, randomized people to either receiving an antibiotic and then receiving a probiotic, or not receiving an antibiotic and then receiving a probiotic, or receiving an antibiotic and not receiving a probiotic. So you've got these different arms of the study, right? Because, you probably heard, most people will have heard that, a doctor will suggest that you should take a probiotic after you've taken an antibiotic to repopulate your microbiome. And that doesn't make any biological sense because the vast majority of probiotics on the market don't really contain human gut bacteria in them. Yeah, there are some, but not many. And even if they did, it's unlikely that the bacteria you consume are going to live and grow inside your intestine. So this study actually did demonstrate that in about 15% of people that received an antibiotic and then took a probiotic, the probiotic did start to grow in their gut. And interestingly, it grew in the duodenum, the bit between your stomach and your small intestine, right? Where it's not supposed to grow. And in those people, those 15% of participants in the study, the growth of this probiotic in their intestine actually retarded the redevelopment of their own microbiome. Their gut bacteria couldn't compete and were actually stopped from growing back because of the probiotic. So now there's no evidence that it caused any health concerns or problems, but it is an interesting phenomenon, right? If you think your microbiome is beneficial, then you might not want to stop it from growing back. So, I always say, what do I do when I have to take an antibiotic? And I do occasionally. I eat a lot of fiber. The best strategy to bring your microbiome back to health, if you were healthy before the infection, right, or the disease, the best strategy is to feed your bacteria, to give them enough food so that they can regrow. And the best food for beneficial bacteria is fiber, right? So I try and consume a lot of plant species, try and get 30 or more plant species. A great study called the American Gut Project, which I was affiliated with, demonstrated that people who eat a lot of different species of plant, 30 different species of plant in a week, have more chemical diversity in their blood. They've got more plant chemicals and bacterial chemicals that come from the bacteria digesting the plant, and a more diverse microbiome, which is potentially more beneficial for their health, right? So I just try and increase the amount of fiber and the amount of different types of species I eat in order to allow my microbiome to naturally repopulate or repopulate my gut environment, right? So that I can get back to health. So
you have some
it's
crazy
complicated.
salads. You have some crazy salads.
Yes.
With
avocado, because I live in California, so you got
to have avocado.
Californian, it's an absolute necessity.
No, you said it's called American Gut Project.
Yes, and you through a organization at UCSD, and my colleague Rob Knight, there's an organization called the Microsetter Initiative that runs the American Gut Project. So you can still get your microbiome sequenced, and the idea is that you pay to have your microbiome sequenced, and all of that data goes into this public repository, obviously de-identified, that scientists like me can use in order to contextualize our small little clinical study in the scale of a human population, right? So there's 30 or 40,000 microbiome results in this collection. And so when I find that this bacteria seems to be associated with protecting against the development of Alzheimer's, right? I can go in and say, well, yes, but I've got that in my population of 50 patients in my hospital, and yes, it does seem to be associated with the development of Alzheimer's. So now I can go and look at the prevalence of that bacteria in the American gut population and say, well, did anybody in the American gut study report having Alzheimer's or report Alzheimer's in their family? And does this bacteria that I found in my clinical study associate with Alzheimer's in this, the entire American population? And anybody can access that, right? It's a free resource. So by providing your sample to the American Gut Project, you're actually supporting the development of the science, which underpins all of the findings that can help us to really translate this research into the clinical setting and improve people's health.
I think we have a link at the end of this. We'll have a link for that, for your site that I believe has a link to that.
Sure.
Yeah, fascinating. And when all this, with your studies of all these, because it sounds like a lot of these studies are cutting edge. I mean, you don't even know yet. How far along is mainstream science on accepting this or understanding the role of microbiology of what you work? Is it still on the cutting edge where people are like, what's that guy Jack doing? Or is it more like, hey, this is a whole new part of science that we need to get on board? Where is it in the bigger scene of science?
In the bigger science, we are just dipping our toes in the ocean, right? It really is a start to understanding this. And if you think about it, we've only really been exploring this for the past 15 years or so, since about 2005. I mean, there were fringe scientists, if you want to call them that, like me and others that were exploring it before then. But in terms of investment, federal investment and commercial investment in microbiome science, that's only really been happening for the past 15 years. So it's still a very early science, right? It took decades, multiple decades, to get genetic science to a point where it was providing any kind of clinical benefit. The obvious clinical benefit is in the detection of cancer subtypes and identifying which treatment you should take for cancer based upon the genome of your cancer, right? So that took 4 or 5 decades to get to that point, and trillions of dollars in investment over time, right? In multiple countries. We're just starting, right? In microbiome science, we're probably at the $1 billion of investment phase in multiple countries, but we only have one FDA-approved clinical therapy that's based on the microbiome. And that's the idea of a fecal microbiome transplant, where we take the poop from a healthy person and we put it into the intestine of a sick person who has, and this is the only disease it's approved for outside of the clinical trial, for recurrent C. difficile or C. diff infection. So when you get infected by a C. diff bacteria and it grows in your intestine, if you take an antibiotic and it doesn't go away, then you can take a poop transplant from a healthy person via your doctor, and that has about a 90% success rate in treating the infection, because the poop bacteria from the healthy person help to re-engineer your gut ecosystem to stop the C. diff from growing. It's absolutely wonderful therapy. Actually, the Chinese were using it almost 1,500 years ago. They called it yellow soup. The fermented stool from an infant, a healthy infant, could be used and consumed by someone who had chronic diarrhea, and it was highly effective in treating the disease based upon ancient Chinese medical texts. But now we don't make people eat the poop in a soup. We instead go off the other route as well. But yeah, that's the only clinically approved, FDA-approved clinical therapy of the microbiome science. Everything else is commercially mandated potential, right? And it's difficult to get it into the clinical setting because it takes many years and millions of dollars of investment to develop it in an effective way that's safe.
But I mean, extremely exciting. I mean, if you already have one, I mean, that's, the door's open. It sounds like it's just time. It sounds like there's a wave going of biology that's really going to take off. Maybe.
I don't mean to interrupt you, Arthur, but it's huge, right? There are tens of clinical trials at a late stage. We're on the cusp. We really are of seeing a lot more translational impact from the science. But the research has just got to a point where we're able to pinpoint the mechanism by which the microbiome actually influences aspects of health, right? And so in the meantime, while we're waiting for all of these clinical therapies to get to the approval stage and then work their way up into drugs that can be commercialized and sold to patients for therapy, what we're actually looking at are ways that you can help yourself. And so I like to say that my mother told me everything I need to know about microbiome science before I was 10 years old, without ever knowing what the microbiome was. When she told me to eat healthily, do some exercise, get outside more, and you'll be healthy, right? We've known that for hundreds, if not thousands of years. There are ancient Roman and Sumerian texts that talk about the importance of physical health, right? And exercise and diet playing a key role. This is not new ideology. It's just now we're figuring out why it's important. Why should you eat more salads? Why should you eat more fiber? It's because it feeds the bacteria in your gut. They then produce chemicals which shape your immune system, your endocrine, your hormones, right? And your nervous system. We know that eating the right kind of fiber can promote the growth of bacteria in your intestine that can produce neurotransmitters that affect your brain chemistry, right? And that can be helpful in improving your mood.
What fiber is that? Tell us.
I know, right? Everyone wants to know that. Cellulose is a good one. It can feed organisms called bacteroides that produce these compounds. Also, things like beta-glucan. That's another one that can be quite effective in helping to.
Where do I buy beta? Where do I buy this?
Well, this is the thing, right? You can buy all these on Amazon. Just type in the names. But the best way of doing it is just to eat a diverse diet. I mean, if you have access to it and you can afford it, and this is the sad fact in America, is a lot of people literally can't get access or can't afford these kinds of food substrates, which is crazy, right? Because they're just plants grown in the ground. But that's the setup of our nation. When your local grocery store is a 7-Eleven, you tell me how easy it is to eat healthy, right? Mm-hmm. But in the context of this, it's pretty easy just to get a farm box from your local farm group, or go down and just buy as many different types of lettuce and vegetables and fruits as you can. There's this adage: eat the rainbow. Eat as many different colored fruits and vegetables as you can, right? And doing that, introducing that into kids' diets early in life. I know I've got 2 boys. It's really hard to get them to eat their vegetables. But doing that early in life can really change the dynamics. Them seeing you eating those things will help to normalize it for children, right? Yeah, so eat the rainbow. Eat 30 different species of plant each week. And that's like, is a way of doing it, but you can you think about it. Well, banana's one species, and apple's another species. That's 2. You got lettuce. You got multiple different types of lettuce. You got cabbage. And cabbage and broccoli and Brussels sprouts are all the same species, but they're different variants. So you could class those, right? Carrots and potatoes and more. So that just diversifying the types of plants you eat and putting them into your diet on a regular basis could be transformative in helping to improve your health. And it will have big impacts, right? I believe personally, and there's a huge amount of data to back it up from international nutritional campaigns, that eating a healthy diet could significantly ameliorate the vast majority of chronic diseases, cancer rates, cardiovascular diseases that plague our modern day communities, right? And it seems so simple, but it's literally just overcoming those social norms about diet interventions that have got stuck in our society, right? We want to eat 2 meat and veg in England, and you got to have heapings of mashed potato and lots of meat in an American diet, and those are ingrained in our psyche as things we deserve, things we should have, and it's actually probably harming us way more than we ever thought possible.
So for people and I'll speak for myself, that really get excited about this stuff, because you really make it really fascinating. Are there any good books, or where's a good first step somebody could take that's like, I want to dive deeper into this? What do you recommend?
I mean, you can buy my book. I always like that when that happens. So Dirt is Good.
It's called, Jonathan put up, it's called Dirt is Good.
Dirt is Good. Yeah, you can find it on Amazon. That was literally myself and my colleague Rob Knight. We used to get so many questions about the microbiome and so many opinions based upon questionable sources that people found on the internet, right? Which we now know is causing problems in our political sphere as well as our health sphere. We wanted literally just to put down question and answer formats about what the microbiome could be doing for your child's health and what evidence there is to support decisions that parents and people can make generally about microbiome intervention. So it's almost like a question and answer guide to developing a healthy immune system. So that's a good one. There's microbiome cookbooks out there you can buy, and most of them are based upon evidence to support the idea that eating the right kinds of food will stimulate the gut community. And so if you're into cooking from a cookbook, then those are really good options, right? This is the problem with the internet is there aren't many trusted sources, and the vast majority of the programs out there would be very hard for one person to interpret as to whether they're telling the truth or not. That's why we have regulatory agencies, so people don't have to spend the time trying to figure out if this is true or not. But for the most part, those don't exist on the internet, so it's hard. But I'd say those are good. Those are good sources.
No, it's fascinating, the fact that it's such a brand new part of science, yet it all just confirms the grandparents' wisdom of eons what to do. But again, for those people that need that why, or why the grandparents were saying go do this, maybe it's an advantage that you're saying, well, here you know what you should, here's the why. Fascinating. And I want to start rolling things up because we end this at 8:00. God, so many questions. What's one of the questions? What's one of your favorite questions to answer that wasn't asked or it didn't come up with your?
I'll give you one of my favorite adages. This comes from fantastic work that we've only just recently understood. Right, both my children had pretty wet poos when they were babies. Right, their diapers were often filled with a wet, sticky poo, and everybody I knew, all the parents I knew, had the same issue, and just assumed that babies, because they're drinking milk, have wet, sticky poos. That's actually not true. In the developing world, the vast majority of newborn infant stools actually be quite solid, right? Like a normal stool. Because their gut microbiome is processing the breast milk they're getting and digesting it, so that what comes out is just the waste products from that digestion, and that produces a full stool. And examining this, we found through numerous studies around UK, America, Canada, and China, that in developing nations, multi-generational use of antibiotics and poor dietary choices have led to the eradication of certain bacteria in our children's and our gut microbiome that are explicitly designed to digest breast milk. These things like Bifidobacterium longum infantis, right? It's almost co-evolved with us to consume the oligosaccharides, the sugars, the complex sugars that exist, that mother produces in breast milk, right? So when a baby consumes breast milk, if it has Bifidobacterium longum infantis, that bug will eat that breast milk sugar and use it to produce chemicals which are actually beneficial for baby's health. If you're missing that bacteria, then consuming the breast milk, the vast majority of those complex sugars just end up in the stool, which is why it's sticky and wet, right? And that to me is fascinating. So now there are companies out there that are taking Bifidobacterium longum infantis and using it in clinical trials, reintroducing it into newborn babies' diets as a probiotic, and it's having wonderful effects upon reducing negative health outcomes, especially in preterm infants, which are obviously our most fragile children in the current clinical setting. So we wanted to tackle them first, and so that kind of strategy is phenomenal, right? We've eradicated organisms in our life that, if we add them back in, could have profound effects upon our health. So I'm very excited about those findings.
I mean, really fascinating. And again, the book is called Dirt is Good. and Jonathan's going to pull up the contact information because I want to start rolling up. But I really want to thank you for being part of this. And you're always a fascinating person to talk to. And a favorite story that I tell people, when I first met you, when you were working at Argonne National Laboratory, and I met Jack, and he was I don't know what you're explaining, but you got me excited. And there was a whiteboard that was on the floor, and you got down on your knees, and you had a cup of tea in one hand, and you were stirring it with scissors, and you're blabbering and talking about microbiomes, and I'm like, this guy's, I don't know what's going on, but this is amazing, and I was so glad to be part of it.
It's good times.
Yeah,
I haven't changed much.
And I know we didn't talk about the book in the pre-interview, but I think that's a great place for people to start with Dirt is Good, because this area and your TEDx Naperville talk talks a lot about these smart pills and some other things. If you haven't seen the TEDx Naperville talk, please watch it. It's amazing. I mean, it's really fascinating. It's like a whole new COVID and all the therapies they're doing there are getting the limelight, but there's a lot of fascinating things that you were talking about earlier, Jack, that you didn't even talk about today, that are really incredible. It's like science fiction science in a good way. But yeah, I really want to, any last parting words you want to share with anything?
Everyone should just remember to eat healthy, get out there, go and take a walk in the wilderness, and get some exercise and rescue a furry pet, and you'll find your life enriched in many ways.
Yeah, and thank you so much. And as we close out, I'd like to thanks everybody for joining us for the TEDx Naperville virtual salon. We're going to have our next salon on February 23rd with Lucas Parra. I'd like to thank our partner of the evening, No More Webinars. If you're sick of webinars, if you produce webinars, there is a better answer, nomorewebinars.com. And I'd like to thank everybody for joining us. If you want to volunteer, if you have an idea you want to be a speaker, or if you want to partner with us, please go to our website, TEDxNaperville.com. We are going to be doing some exciting things this year that are different. And hang in there. We're going to be with you guys through this whole pandemic, January, February, March, April, May. We have some other speakers already lined up that are secret for now, but we're going to be doing a lot of activations. We'd love to have your help. If you're bored in your home and you want to do something and you're tired of Netflix, volunteer. We're trying to build up a team to do some incredible things. And thanks, Jonathan, for producing it. Thanks for Michelle for handling the comments. Thanks, everybody else. And thank you so much. That's it. Thank you.